Okay, so this is example 3 of optimization. This one is probably, of the ones that we're doing, it's probably the one that's a little bit the most fun. Let me put it that way. Okay, so we want a right triangle formed in the first quadrant by x and y axis and a line through the point 1, 2. So once again, we want to start by drawing a picture. And we know that this goes through the point 1, 2. And because it's on the axis, we know that this point would be 0, y, and this point would be x, 0. Now, the first thing they want us to do is to write the length of the hypotenuse as a function of x. So recalling from Pythagorean theorem, we know that the hypotenuse, the length of this side would be x. The length of this side would simply be y. But they want us to write this in terms of x. So that means that we need to solve for y in terms of x. And to do that, we're going to use the slope formula. So recall from Algebra 1 or Math 1 or wherever that's taught now, that the slope is y2 minus y1 over x2 minus x1. So the slope on this line is the same no matter where I take it. So I'm going to write two expressions for the slope. The first one is going from the point on the y-axis to 1, 2. So if I write a slope between these 2 points, I get 2 minus y is equal to 1 minus 0. That has to equal to the slope if I write the slope from these 2 points. So the slope from those 2 points would be 0 minus 2 is equal to x minus 1. And what I want to do for this is I want to solve for y. So I'm setting these equal to each other and solving for y, and I get 2 minus y is equal to negative 2 over x minus 1. Solving for y, I get y is equal to 2 plus 2 over x minus 1. So I can simplify that. Finding the least common denominator, I get 2x minus 2 2x minus 2 plus 2 over x minus 1, or simply 2x over x minus 1. And that is my value for y. So now going back to what it asked me to do is to write the length of the hypotenuse as a function of x. My hypotenuse is then x squared plus y squared, which would be 2x over x minus 1 quantity squared. And of course, I could write that as x squared plus 4x squared over x minus 1 squared. And that is actually the answer for that. Okay, now let's do the second part. Find the vertices of the triangle such that the area is a minimum. So if I want my area to be a minimum, going back to the equation that I just had, let me draw that again. So remembering that this is 0y and this is x, 0. The area, my primary equation, is going to be 1/2 x times y, the area of a triangle. Now, we just, in the previous problem, we solved for y. We said that y is equal to 2x minus 1. So this becomes my secondary equation. Y is 2x over x minus 1. So that gives me 1/2 x times 2x over x minus 1. And of course, this simplifies to x squared over x minus 1. Now, in order to determine if it's a minimum, I've got to take the derivative. Okay? So, we take the derivative of this and we get, we're going to have to use quotient rule. So we get the derivative of A with respect to x. We do low times the derivative of high minus high times the derivative of the low, all over low squared. So that gives me 2x minus 2 minus 2x. I got a problem here somewhere. Where did I make a mistake? This is 2x squared. Okay, so let me do that again, because that should be, no. Low times the derivative of high, which is 2x. I know I made a mistake somewhere. Low times the derivative of high minus high times the derivative of the low. Okay, I made a complete mistake. Let's start over again. Sorry. Low times the derivative of high minus high times the derivative of the low, all over low squared. I think I did it right that time. So that gives me 2x squared minus 2x minus x squared over x minus 1 squared. So this gives me x squared minus 2x over x minus 1 squared, and I want to set that equal to 0. And I'm going to find all the places. Remember, it's where the derivative is 0 or undefined gives me my critical numbers. So where's this derivative 0 or undefined? It's 0 at x equals 0, x equals 2, and x equals 1. Now, we could do a sign chart for all of these, or we could eliminate some choices. I know that x cannot equal to 0 because if x equal to 0, that would be just a straight line. I know that x cannot equal to 1 because this point is 1, 2. So if x is equal to 1, that is no longer a triangle, that is a trapezoid. So my only possible answer is x equals 2. Now I need to see if that's a max or a min. What am I trying to find? I'm trying to find a minimum. In this case, taking the second derivative is not feasible. It is, but it's kind of complicated. So I don't want to take the second derivative. So I'm just going to use, go back to using a sign chart. So I do 2. And remember, I placed that into the derivative itself. So if I take a number, let's say 1.5, because 1, it's outside of its domain. Well, I guess I could do 1. So if I place 1 here, well, I can't because that's outside of the domain. If I do 1.5, I get a fourth minus, no, I get, if I do 1.5, which is like 3/2, I get 9/4. So I'm going to get a positive number. The bottom is always positive. If I put in 3, I get 9 minus 6. 9 minus 6, I get positive. Apparently, if I put this in, I get a negative. So I'm going from a negative to a positive, so that gives me a minimum. I'm trying to do this without actually doing the math for it, but I know if I put in a negative, if I put in 3/2 here, I get a negative. Because I get 9/4 minus 3/2 times 2 would be 3. So 9/4 minus 3, negative. So I see that I get a minimum. Okay, and so what was the question? The question asked, find the vertices. So the vertices would be x is 2. So this would be 2, 0. So my vertices would be 0, 0, 2, 0, and then I would have to go back to y and figure out what y is when x is 2. And y was equal to 2x times x minus 1. So if I put in a 2 here, I get 4 minus 1. I think that's right. So I get 0, 4 would be my vertices. I think that's right. My math may be a little off there, but the process is correct. All righty, that was example 3. Come back for example 4.